Okay, we want to look at an important improper integral example. And in this example, we want to know when you integrate from 1 to infinity, 1 over x to the p power with respect to x, what we want to do is we want to know for what values of p does this integral converge. Okay, and what we're going to do is we're going to break this up into cases. So case one, p is equal to 1. So when you take a look at that, you're going to get this integral from 1 to infinity, 1 over x dx. And this was done earlier. This was example 1. Okay, so we discussed this in class. Let's take a look at case 2. Case 2 is going to be the situation where p is not equal to 1. Okay, so let's take a look at this situation. So as we know, we need to use a limit to evaluate the improper integral. So we're really going to integrate from 1 to some finite number t. Our integrand is going to become x to the negative p dx. And we're going to take the limit as that upper limit of integration goes to infinity. All right. So let's calculate the antiderivative. The antiderivative is going to be x to the p negative p plus 1 divided by negative p plus 1. And we're going to evaluate that as we go from 1 to t, and we're going to take the limit as t goes to infinity. Okay. So this number in the denominator, negative p plus 1, this is a constant relative to t. So we can factor that entirely out of our integral. So our integral is going to become 1 over, I could really write this as 1 minus p, and then we're going to have the limit as t goes to infinity. We're going to substitute in a t, so we're going to have a t to the 1 minus p, and then we're going to substitute in a 1. So we're going to have minus, really it's going to be 1 over 1 minus p. Okay, so this part comes from substituting in t. This part comes from substituting in a 1 for x. So this second number here, this is just a finite number. It's not going to affect whether your integral converges or diverges. So the part that we really need to look at is we really need to study this part right here. We need to look at this limit piece, and we need to see, does this limit piece right here, does that converge or diverge? So let's see what happens. I'm going to take the limit as t goes to infinity. I'm going to have t to the 1 minus p power. And I'm going to break this guy up into 2 cases. So the first case is, what if p is greater than 1? Okay. If p is greater than 1, then when we look at that exponent, 1 minus p, that exponent is going to be negative, right? That means that t is in the denominator, which means that when you take the limit as t goes to infinity, this t to the 1 minus p, the denominator is going to get really large while the numerator remains a constant. So this part is going to go to 0. So the upshot of this is that when p is greater than 1, the integral converges. Okay. So I'm going to highlight that. This is a very important result for us. Let's take a look at the other case. So in the other case, that's going to be when p is less than 1. When p is less than 1, that means that the exponent 1 minus p is positive, right? And that means that t is in the numerator. When t is in the numerator and you calculate the limit as t goes to infinity, you're going to get that your t to the 1 minus p, because your t is in the numerator is exploding to infinity. So that means that this limit's going to go to infinity, which means when p is less than or equal to 1, your integral is going to diverge. So I guess I forgot to mention earlier in example 1, we saw that this integral diverges. So I should have probably wrote that integral diverges. All right. So what we've done is we've done a systematic case-by-case analysis studying this particular integral involving p. And what we've seen is that when p is greater than 1, this converges. When p is less than or equal to 1, it diverges. So we're going to use this fact in the future when we go to chapter 11. So this example is super important for us. All right. Take care, everyone.